Hello, everyone. Thank you for being here today and joining us from near and far. So depending where you're logging in from, good morning, good afternoon, and good evening. Thank you for logging in for our sample lecture on prescriptive analytics today. We've got an engaging hour for you all, and what we're going to do is we're actually going to start off with some quick introductions of who's in the room today. And then we'll get into the sample lecture for today's session. So the sample lecture is going to be led by Dr. Steven Shechter. Steven is one of our highly esteemed professors, and he'll be speaking to prescriptive analytics in his sample lecture for us. We're also going to be having some time for some Q&A for Dr. Shechter. So if you have any questions about the topic, feel free to type them up in the chat or in the Q&A box throughout the session, and we'll try to get to as many as we can during that component. And following this part, we're actually going to give you all the opportunity to connect with some of our Masters of Management and our Masters of Business Analytics program alum. So you'll get to do this in smaller breakout rooms where you can ask program-related questions, admissions-related questions, and any kind of questions you might have for alum about their experience in both the MM or the MBAN program. So stay tuned for the breakout room links. We'll be posting those later on in the session after the sample lecture component so that you will get that chance to connect with our program alum also. I'd also like to acknowledge that UBC's Vancouver Point Grey campus is situated on the traditional ancestral unceded territory of the Musqueam people. And I'd also like to acknowledge that you're joining us today from many places near and far, and acknowledge the traditional owners and caretakers of those lands. And now for some staff introductions. I'll start off by introducing myself since I have the mic. If I haven't already had the pleasure of connecting with some of you, I'm Natalie Serestrafil, and I'm one of the recruitment and admissions managers at the graduate school, and I oversee the Masters in Business Analytics program. I'm joined tonight by some of my great teammates, namely Kevin Lee, who is also a recruitment and admissions manager. Hi, Kevin. And he oversees the Masters in Management. We call that the MM. We also have Tara Lynn Wong with us today. She's our marketing and communications co-op student, and she's going to be supporting us through this event today. So thank you both for joining me today. And now without further ado, I'd like to introduce our very special guest. He's the real reason you all are here today, let's be honest. So you're joining us for an engaging and informative sample lecture on prescriptive analytics. So Steven Shechter is a professor at the Sauder School of Business at the University of British Columbia. His research focuses on applying operations research to improve decision-making under uncertainty, with a particular focus on healthcare applications. Steven teaches courses in both the MBAN and the MM program, and he speaks to primarily to optimization and simulation. So you'll get a sample of that today during the lecture. He's also the director of the Center of Operations Excellence, which provides real-world analytics project experience for some of our students. And throughout his career, his research has focused on applying dynamic programming and simulation techniques to decision-making in healthcare, amongst other industries. He's also been awarded a Career Investigator Award from the Michael Smith Foundation for Health Research for his work in this area. Steven is a past recipient of the Informs Bonder Scholarship for Healthcare Research and is the 2012 president of the Health Application Society for Informs also. Steven has also worked at United Airlines Revenue Management Department and has taught simulation modeling workshops at the University of Chicago. So a sincere thank you to Dr. Steven Shechter for being with us. And with that, I'll turn things over to you, Steven. Thank you.
Great, thank you for that introduction, Natalie. It was way too much talking about me. I don't like hearing so much. So I'm glad to now have the mic to talk about some of the things you alluded to. And let me share my screen here and start doing that. But it was a very nice introduction. Thank you. So let's see. There we go. Okay, does that look good there? Yeah. Great. Well, welcome everyone. It was just amazing to see all the different places people are tuning in from, and it's an honor to have your time from all over the world to listen to some of the things that I'm going to talk about this evening here in Vancouver for me. And what I'm going to do is I'm going to talk about some of the different things that I cover through a variety of courses I teach. So this is not an actual course per se, but I'm going to talk about some things that come up in the kinds of courses I do teach at Sauder. And before I get into prescriptive analytics, which is the focus area of this sample seminar, let's just talk about kind of the lay of the land of analytics in general. And this has been playing a huge role in the business community over the past decade or so. We're all hearing about business analytics, big data, AI, machine learning, and so forth. And so I'd like to situate what I'm going to focus on tonight in the broad spectrum of business analytics here. And so when we hear about analytics, we often hear about these three major areas of analytics: descriptive, predictive, which Natalie mentioned before, and prescriptive. And it's like a tongue twister. And so I understand when you said prescriptive, you initially said predictive, but there's like, every time I say this, I get tripped up on descriptive, predictive, I do that all the time. But that is another area of analytics, predictive analytics. And there's overlap with these different areas, but let me just give just a brief snapshot of what these different areas involve. And so on descriptive analytics, it's often about trying to glean insights from business operations as they've been, and trying to understand what the data might tell you about the current system. So this often involves just collecting data on the current processes in the organization and doing some simple things like data visualization, some summary statistics, and things like that. So if you've heard of like Tableau or Microsoft BI, these are data visualization tools for really helping understand a lot of the data for the way things have been in the organization. Okay, and that could shed a lot of insights on where there might be opportunities to improve the processes in the organization. The next kind of step in the analytics maturity cycle and spectrum is what's called predictive analytics. And this is going from, understanding the way things have been to understanding what might happen in the future if you make certain changes to the system based on, a variety of things you have seen in the past. So for example, when you apply for a loan, they'll collect some demographic information on you. They'll, and put this into some kind of predictive engine, and that engine is going to try to decide or predict what is the likelihood you might default on this loan. Okay. And so when you apply for a credit card or a loan, sometimes, they get an answer to you very quickly. And in the background is running some kind of predictive analytics algorithm to try to say, you're going to be a good recipient of the loan, or you're going to be problematic. Okay. We're all probably familiar with recommendation engines like, Netflix. If you watch these shows, you might like these other shows. Amazon, if you purchase these books, you might like these other books. So this is when we hear about analytics in the popular press, which we hear about it a lot these days. Often it's focused on predictive analytics. So I'll be upfront about that most of the analytics we hear about is in this space. But there's this huge area of applied work from analytics that I'm going to talk about that is affecting our everyday lives in so many ways that we might not be aware of. It doesn't get as much media attention, but it's been used for over 50 years in many industries. And that's what I'm going to focus on with prescriptive analytics. And so this is kind of taking the next step in the analytics maturity cycle and saying, okay, we've got a lot of data. We could predict, what might happen if we do, action A, B, or C, or we make decisions, X, Y, or Z. But now, how do we optimize? How do we decide what is the best course of action? So the prescriptive analytics, the prescriptive part is, prescribing a course of action. So it's really focused on integrating these first two parts of analytics into a decision-making framework to try to make good data-driven decisions. Okay. I'll give some examples in the remainder of the time, but briefly, for example, how do you route, UPS trucks to make efficient deliveries and minimize distance traveled, for example? How do we schedule nurses at a hospital who work on different shifts, and we need someone to cover each of the shifts? And some people can't work these days. Some people have preferences for working these other times. And how can we how can we try to find a work schedule that might work best for everyone? So methods in the area of prescriptive analytics and methods that I teach specifically include mathematical optimization and computer simulation and decision analysis. Before I go into some of the examples that I'll show you, how I might solve it in Excel or with Python, for example, let me just mention that if any particular business area you might be interested in could probably benefit from all these areas of analytics, including prescriptive analytics. So these are just, some of the many industries where these techniques are being used. And so, whatever your interest is in the business world, there's a place for these kinds of tools. Okay, just to give you a little bit more of examples of success stories in the past. There's I grabbed this from a textbook on prescriptive analytics. And what I like about these examples that come from this book is that you see a wide variety of industries here. You see an oil company, you see IBM, you see an airline on the left, right? You see a police department, you see a health department, right? So there's healthcare, there's logistics companies, and these are just 5 of many, many examples. Why would Texaco use these kinds of methods? Well, they might want to try to figure out how to create blends of gasoline products to meet some kind of environmental quality constraints and regulations, and do so in a cost-effective way. Why might IBM use these kinds of methods? Well, they have this huge network of spare parts, and they have to do inventory management around this to support their many offices and locations. Why might an airline use these? Well, I'll give you an example in a little bit, but the example here, and the example I'll give you like a small version of what's shown, of what's discussed here, is that they use this, for example, to decide how many seats to oversell a flight by, because they know that people cancel, people don't show up. And so airlines actually sell more tickets than they have physical seats available, okay? And I'll show you a little Python example of that shortly. Why might a police department or say ambulance department use these methods? To think about where to situate police cars or ambulances, where should they be roaming throughout a city to provide adequate coverage in case there's an emergency, right? And then this last example is, what I like about this last example is that on the right column, you don't see a dollar figure. You see, something related to lives saved. And so these analytical tools are often used to improve the bottom line and maximize profit, so to speak. but sometimes they're used for social benefit kinds of reasons and improving health outcomes, and and they're used in trying to improve voting access and all kinds of interesting social good and big social welfare kinds of settings. Okay. Like I said, there's something for everyone with prescriptive analytics. The kinds of tools that I talk about in some of my courses and that we may use to address some of these problems include, for example, a free add-in that some of you may not even know you have with your Excel software right now. It's an add-in called Solver, and it's used for doing optimization modeling. I'll show you a small example shortly. A lot of you have probably heard about R and Python, which are big programming languages for doing a lot of analytics these days. And I'll show you an example of a Python program that could help an airline make that decision about how many seats to sell on a flight. There's other software. I'll give you an example of the software called Arena for doing what's called discrete event simulation, and I'll explain that more in a little bit. Okay, but all of these tools, and there's others out there certainly, are all methods for helping us make better decisions, and for certain kinds of decisions, some of these are more appropriate than others. Let me give you an example of a famous problem in computer science and applied math, which is called the traveling salesperson problem. And it's a problem that's really easy to state, but it's really difficult to solve very large versions of this problem. And it's a great motivation for why we want algorithms and some of these math optimization tools to solve these kinds of problems. And it's also very applied. This problem is very applicable to what I mentioned earlier, these kinds of routing problems that companies like UPS and FedEx face every day. They have to decide where to send their trucks and what order should they visit different retail locations, maybe different cities, if these are, for example, the trucks or flights, routing flights around different parts of the country. And let me give you an example of that. So there's this application on this website here, which I like to do with my class. It's a game of sorts, but it really illustrates the idea nicely. So I'm just gonna set something up here and just to give you a flavor. Do you see this website here, Natalie? Yeah, okay, great. So this is the basic idea of this optimization problem. Now imagine we have to route a flight that starts off at some base location here in South Africa, and we need to route it to make drop-offs at every city shown here as a dot, okay? Now, and suppose we want to route it, so from here I might go to this city, and then from here, maybe I'll go here, then here, right? And then, but now, and let's say I want to route the flight in a way that I visit every city once and I eventually return back home in the minimum distance traveled possible, okay? Now you might look at this and eyeball this and be like, yeah, okay, go here, then here, then here, then maybe here. And maybe this version isn't that difficult to eyeball and solve just by visual inspection, okay? But let me change the problem up some. And let's suppose we had more cities to visit, okay? And let's suppose I had a route, this is showing on a continent, but you can imagine it at other scales of magnification of the geography. You could have, a province in Canada, you could have a state in the US, and it could be, different locations that you're routing a truck. But here, since it's such a large geographic area, imagine it's an airplane that, is having to go to all these places and return back to the base airport in a minimum distance. Okay. This is not something we want to solve by trying to just eyeball it and try to guess what looks like a good solution. it would be wonderful to be able to just solve this exactly using some mathematical optimization or prescriptive analytics tools, okay? And if we do that, so basically what I just did is I said, show me the optimal solution, okay? And this is the optimal solution. I should go from, from here to here to here to here and so on. And it tells me the total length of the distance traveled. And what this is guaranteeing is that I cannot do this in a shorter distance possible. There is some prescriptive analytics algorithms going on beneath the scenes and creating the solution that does not involve any guesswork whatsoever. And so, you can imagine that a lot of savings in fuel and time could be gleaned by using these prescriptive analytics methods instead of trying to solve things by just, paper and pencil, so to speak. Okay, so that's one example I wanted to share with you. So, and even if you were good at doing this visually, wouldn't it just be nice to just, snap your finger and have the solution done for you, okay? So that's the idea of that. Now, here's another example, also a kind of logistics example. And this is an example I go over in class, where, imagine you have these 3 factories producing furniture in Winnipeg, Montreal, and Halifax. And they distribute to these regional warehouses in Edmonton, Toronto, and Ottawa. Now, suppose that you have some data on the problem. Oops, let me put this in full presentation mode. And so, now we're going to talk about constraints, right? Winnipeg only has 100 units on hand. Montreal only has 300, let's say, desks on hand, okay? And Edmonton only wants 300 units. Toronto wants, the warehouse there wants 200 units and so forth, okay? Now there's also these shipping costs. So to ship one of these desks from, say, Winnipeg to Edmonton costs $5, but from Montreal to Edmonton costs $3 and so forth. Now suppose that you want to ship all of these desks from the factories upstream to all these warehouses downstream in a way that is the least costly way to do it and respects the constraints of the system, which says, okay, we have some supply constraints and we have some demand constraints, okay? Now, again, you can maybe sketch this out, paper and pencil, and try to figure out, okay, let's see, it looks like it's really cheap to ship from Montreal to Ottawa. Maybe we should do as much of that as we can. But first of all, I'm only showing you 3 suppliers and 3 warehouses. Imagine there's many more. It's the kind of thing that you're not going to want to try to solve by paper and pencil. It would take way too long. There would be too many combinations to work out. And so this is where we could use a tool like Solver that I mentioned in Excel, which I'll bring up here. So for example, this is the Excel setup of the problem I just showed you on the PowerPoint. Here's the unit shipping costs from all the suppliers to all the retailers. And I have these constraints that say, okay, the amount of stuff you send out of Winnipeg cannot be more than 100 because that's all the supply you have. And so that, that's why it says less than or equal and so forth. Now, what you may not have ever played with is in the data tab, after you plug in the add-in for Excel Solver, there's this solver thing here, okay? Yeah, it comes free with Excel. It's there for the use, for your using. So if I go there, I've already set it up, so I'm not gonna go over all that. But look in the yellow section of the spreadsheet over there where it's all blank right now, because when I hit solve, it's gonna tell me what to do. And this is what prescriptive analytics is all about. It's about prescribing a course of action. So what should I do? I should send all of my supply from Winnipeg to Toronto. I should send all of my 300 units of supply at in the Montreal factory to the Edmonton warehouse. And of the 300 units I have on hand at Halifax, I should send 100 to Toronto and 200 to Ottawa. And my total cost is $3,000 of this shipping plan. And what Solver is doing and guaranteeing for me, taking the guesswork out of this, is that it's guaranteeing that I can't do this for any less than $3,000. Okay. So again, it's nice. I could automate this. I could set this up. And once I know how to set these problems up, I have these tools, these algorithms, these software products that can help me solve it. Okay. So let me just jump back here for a moment. Okay, so that is that. Now let's go back to the airline overbooking problem. And I actually worked for United Airlines for 2 years a while ago doing this kind of work where we were trying to decide using the kinds of tools I'm going to show you in more detail, but at its core, it's really the kind of thing I'm about to show you to decide, okay, for imagine you have an airplane that has 100 seats. Physically, it only has 100 seats, okay? And each ticket sells for $300. Now, now suppose that 10%, historically, 10% of the people who buy tickets don't show up. And that's not unusual, actually, for an airline to have a 10% no-show rate. So let's suppose you just sold 100 tickets on that flight. Well, if 10% of the people don't show up, then you have 90 people leaving on the flight, 10 seats empty, and that's kind of a waste because the airline would certainly have liked to fill those seats with paying passengers, okay? So they get into this game of, well, okay, should I sell 101 tickets? I know I have only 100 physical seats, but if 10% of the people don't show up, then I'm probably okay, you know? Okay, now should I sell 102 tickets? At what point do you stop and say, okay, maybe if I sell 110 tickets, now it's getting close, because if I take off 10% of 110, that's 11 no-shows. Now I'm at like 99 people on the flights. I'm getting close to having too many people show up, right? And many of you may have been in an airport where you've heard these announcements, right? Have you ever heard the announcement? We're in an oversold situation. We're looking for volunteers to take the next flight out, and we'll give you a voucher, for example, for $500 for use anytime in the next year for travel anywhere in, you know, in the country or something like that, okay? That's because they're in a situation where too many people showed up for the flight. They sold too many tickets. Not as many people no-showed as they thought. And now they have maybe 102 people showing up for the flight. They are there physically at the airport. But they only have 100 seats on the flight. So they have to get at least 2 volunteers to say, okay, you know what, I'll take that next flight out in 3 hours and get it down to 100 people that fly, okay? So how could they make good decisions about this, right? And plus there's a lot of uncertainty in this. 10% doesn't mean, if I sell 110 tickets, that doesn't mean exactly 11 people are gonna not show up. It just means on average, 11 people may not show up, but maybe 14 people don't show up, or maybe only 8 people don't show up. So there's a lot of uncertainty, and how can we make good decisions under uncertainty? Well, then we get into simulation models, what are sometimes called Monte Carlo simulation models. And this is just a model that, you know, we do in one of my classes. This is in Python, in Jupyter notebooks, but you know, you could see some of the parameters I showed you on that slide. The number of seats on the plane, the no-show chance, the ticket price, and a cost of providing vouchers for too many people showing up. And so, you know, we could use this kind of program to say, okay, how many tickets should I sell? And, you know, this is just basically the code that is, what it's doing is it's going through and it's evaluating, what if I sold 106 tickets? What if I sold 108 tickets or 109, 110? What is my average profit from that flight? Okay. I want to fill more seats. So, you know, overbooking some amount seems to be a good strategy. Remember, there's only 100 physical seats, but it looks like somewhere around 113 tickets to sell, despite only having 100 physical seats, seems to be the right balancing point. Okay. If I don't sell enough tickets, I'm going to have a lot of empty seats when the flight takes off. But we see this kind of counter effect later on. If I sell too many tickets, Well, I'm going to have a lot of people that are showing up for the flight that I'm giving these vouchers for. I'm basically giving them money to take a future flight, and that's becoming expensive. So where's that kind of sweet spot? Well, it looks like, basically this program is saying around 113 tickets to sell. Seems to be like a good balancing point to optimize this average revenue. Okay. So that's an example of a Monte Carlo simulation in Python. Let me just give you one other example of a simulation model that has a very different flavor, and then we'll wrap up, and I'm happy to take questions. Are we good on time, Natalie? Yeah. Okay. So let me just show you this. Okay. And so this is another type of simulation model, but very different in flavor than the simulation I just showed you. Like what I just showed you is just like a bunch of code that is basically cranking through these scenarios of what might play out in a day in the life of the flight. There's not much interesting to really visualize there, but there's some processes that would be very interesting to visualize how a day in the life of, for example, an emergency room might play out. And so, here is a simulation of people arriving to an emergency room. They check in, they get evaluated quickly by a triage nurse to see, how urgent is their situation. Depending on their urgency level, they may get access to a bed sooner than later. And, these are supposed to represent different hospital beds. We have different doctors on staff during this time. We have different number of nurses. And you can imagine that this tool would be very helpful to say, well, what if we had an extra bed, right? What if we had an extra doctor on staff? What if one of our nurses called in sick? Like, what would that do to the system? And so how could we prepare for, the right amount of staff to have, the right amount of equipment to have? And you can see here, there's a lot of congestion building in the waiting room, right? And so if you want to kind of balance, the kind of wait times and reduce wait times for the patient population, well, you're going to have to invest some money and resources. And then it's another balancing act, right? What's the right sweet spot between wait times that you're concerned about for the patient population and the practical matter of the expense of, the number of doctors, nurses, hospital beds, x-ray machines, and so forth that you might need, okay? And so we could use this tool to help prescribe a course of action of how many people to hire, how many resources to acquire, okay? I think I just have, this final, I won't go into screen share, into full presentation mode, but, some of the goals of, again, this isn't an actual course, this is kind of an amalgamation of different courses that I cover. But the ideas across these courses or courses on prescriptive analytics in general, cover these kinds of ideas. And I'll just leave that up there for you to read. I won't bother to read them. And with that, I'm done with my sample class and happy to take any questions. Thank you, everyone.
Great. Awesome. So thank you so much, Dr. Shechter, for sharing that and sharing those insights. And it's definitely always interesting kind of seeing the different examples where analytics can be used and situations that we're not even used to. Like I don't often think about how it might help hospitals, for example. So thank you for that. We do have some time for questions, so I do invite everyone here, if you do have any questions for Dr. Shechter around analytics and the program, do put them into the Q&A box. I'm already starting to see some come in. So why don't we start with this one, actually? So Dr. Shechter, how has analytics changed from your time learning it to today?
I guess I might date myself with that kind of question, but that's a great question. So like I said, some analytics has been used in certain industries for over 50 years. Logistics industries, manufacturing has been a long time user of these tools. But what I would say is, for example, in the last 20 to 30 years, maybe healthcare has gotten on board more with these kinds of methods. And so some industries are, have been seeing the success of other industries, like manufacturing, a long time user of this, logistics operations, trying to improve routing of vehicles, a long time, success story of this. And then other industries have been like, well, yeah, we have patients instead of vehicles, but we still could glean a lot of efficiencies by using these methods. And so I think that's one thing that's changed, and other industries as well. The other thing is that of course with time, there's been massive amounts of data collected. Processing power of computers has I don't know what the every so many years it doubles, or some kind of like Moore's law kind of thing. But so now we could solve larger scale problems than we could ever solve before. I would say that, this predictive analytics that I mentioned has taken off like crazy over the last 10 years. And so now we're seeing more integration of some of these advanced like deep learning, machine learning kinds of tools integrated with some of these prescriptive analytics methods. So there's greater potential for tying those worlds together. And so, yeah, I think processing power and data driven modeling has, gone up significantly over this time.
Thank you. We have a few more questions coming in. You mentioned, of course, examples in like manufacturing. You talked a little bit about, logistics. Paulo asks a question here. Do you have any examples in construction? Or do you know of any?
Yeah, that's great. I love that, because I've always thought that construction has great potential to use some of these methods. And I have a friend who works in construction management, and that's an industry that he'll be the first to say is kind of rooted in some kind of like more, I don't know, old school way of doing things, and maybe has great potential to take on some more of these analytics approaches. So I mean, one, construction involves a lot of project management. And so, one example I go over in my classes is like, how could you estimate timelines of a project, and where could you find opportunities to cost effectively reduce the timeline of a project? How can we use simulation modeling, for example, to understand the uncertainty around project timelines? So, and construction is a prime example of a large-scale project with lots of uncertainty, and we could use these modeling techniques to understand how that uncertainty might unfold and think about how we might mitigate that. So I think that's there are people like we have in civil engineering here at UBC, we have folks doing construction management kinds of modeling using some of these tools. So there is some out there, but I think there's a lot of potential still to go in that industry. My impression, and some of what I've heard from people working in the industry.
Great, thank you so much for that. Great, keep the questions coming in, everyone. Now this is going to be a bit more dialed down into sort of what you would need to do well in the course. We had a question here. How much mathematical knowledge does one need in order to, I guess, go into the course and do well within the courses that you teach?
So I teach primarily in the MBAN program, and so it is it's a fairly quantitative program, like for sure. I mean, regardless of what program you're interested in, if this is an area that you're wanting to pursue career-wise, then it's a very quant kind of area. So, if you've done well in your, your high school and undergraduate math courses, and you don't have math phobia, which a lot of people out there do, then it might be something you like. But even if you're not going to be the algorithm developer or the optimizer or the simulation developer and so forth, I think what's nice is that there is some analytics coverage in all of our programs, the MM, MBA, MBAN, and just knowing that this stuff is out there, right? So that you could, you know, if you're thinking about building a team, you could say, you know, it would be nice to maybe have some of this expertise and get someone in-house for this kind of work, or maybe contract out some of this kind of work. So it's super useful just to know how important and prevalent these kinds of methods are out there in the business world, whether you're going to be the, you know, the getting your hands super dirty analyst, or you're going to be the manager of a team where you want some of this expertise.
Great, thank you. So I have a question here from Annie. Annie asks, what are some limitations with the analytical tools that we've discussed or you've discussed today? Or are there any limitations?
Yeah, that's a good question. So some of the problems out there, although I showed you, like I clicked solve, and that 50-city tour of an airplane through Africa solved quickly, there are some problems out there that do not solve quickly from just implementing kind of a vanilla version of the problem, okay? And so that's where, you know, there are faculty doing research and methods to try to help solve really large scale problems, right? So some of these things that I showed you that I'm just like, oh, I just clicked on solve in Excel and it solved, is not necessarily how some large scale problems would work out. Like if I took a large enough problem for a, you know, medium to large size industry, let's say UPS. UPS is not solving these problems using Excel solver, for example. And so there are still limitations. Despite the huge advances in computational power, there are still problems out there that take way too long for any computer to solve, which sounds quite surprising, but some of these problems scale in ways that are really kind of nasty. And so we need to think about, okay, maybe trying to get the optimal solution is a goal that we have to relax, and we have to think about how can we find good solutions and feel confident about finding good solutions that may not be necessarily optimal. So that's one thing that comes to mind. You know, and of course, you know, in the world of predictive analytics, you have all these, you know, ethics questions about bias and, you know, recommendations, and whether you're, you know, making recommendations that are indicating a bias that you don't want your recommendation engine to be applying. And there's all kinds of unfortunate examples of that.
This sort of bleeds into this other question by Felipe, which talks a little bit about cognitive bias in optimization problems. I guess, like, from your perspective, maybe I can kind of blend another question to this. From your perspective as someone who's worked in analytics, how do we teach analysts to deal with bias, like whether it's ethical or cognitive? And is that something that we do teach our students here in the programs?
I would like to hear more about the kind of bias that Felipe may be referring to. I know we don't necessarily want to like go there in terms of introducing that dialogue or bringing others into this session right now, right here. But so I'm trying to work off your question, Kevin. But you know, and I hope I'm touching upon the question with what I'm going to say here is one thing that I try to emphasize in the courses is that there is a soft side of the field, which is talking to decision makers and trying to understand, you know, their wants and their needs. And so, like, I go through a case study where I pretend like I'm a doctor in charge of scheduling at the hospital here in Vancouver, which is based on a project I've actually worked on. And my students play the role of like analytical consultants. And so I try to give them like a mock example of, you know, kinds of discussions and dialogue that they're going to have with real world decision makers to translate a real world problem into, you know, these software, you know, front ends. And before you could hit solve and before you could set up your spreadsheet, right, you need to understand the real world context, and you have to think about what are the questions to ask, How do I get data? And with that, there might be some bias that, you want to be aware of with the decision makers you're talking to, right? You might know in this industry that there might tend to be this kind of bias, and you have to try to get around that and try to ask questions in a way that tries to mitigate that bias. So I hope I'm reasonably answering the question, but I'm afraid I might be off. But I think a lot of that would come into the softer side of analytics, which is conversing with frontline decision makers and extracting the key information from the real world setting before you even touch the computer.
Awesome. No, I think that definitely hearing from someone who's also worked in industry and who's also teaching the program, like I think the ability to talk about that soft side to analytics is something that can often be missed when we're reading articles and we're reading a lot of different things about, analytics and how it's being used in today's world. So thank you for that example and giving us a bit of insight into how you also teach the program. Thank you. And Felipe said thank you too.
Yeah, and one more quick thing I'll say is that I think a lot of these tools help mitigate the bias just by, when you have, this unbiased machine, it has no bias. It's just trying to find the best answer. And so that that could be quite helpful to get around those issues. So one, you kind of have to detect bias in understanding the real nature of the problem, but then having algorithmic based approaches helps alleviate a lot of human bias that comes into real world decision making.
Great, thank you. We have about maybe 2 more minutes but before we have to jump into our breakout rooms. But there's actually kind of a nice question right here. Do you have some examples, Dr. Shechter, about how some examples of analytics have helped maybe a B2B company?
I definitely, that's not a space. A lot of my work is in healthcare. So yeah, is there a specific company one is thinking of when they're asking that? And I'm trying to nothing. I'm blanking on that right now. So, I mean, there's a lot of auctions that go on in B2B, right? Selling different products from one company to another, and companies putting out or organizations putting out our requests, RFPs, requests for proposals, and trying to get different potential vendors to bid on things, and so a lot of in auctions there's a ton of analytics that goes on, and auction design and things like that. But yeah, I don't that's not an area I work in and have much knowledge about.
Well, I think the example that you brought up is one that I would never have thought of. So already you've offered insight here into this part of the world. So thank you so much, Dr. Shechter. We have quite a few questions coming in today. We have run out of time, unfortunately, for our Q&A here with Dr. Shechter. So the last thing I really want to say is just thank you so much, Dr. Shechter, for your time today. Thank you for dedicating your help here with us. And thank you so much for answering these great questions that have come in here from our attendees. So thank you so much. And we've gotten quite a few different thank yous from people here in the audience. So again, thank you for your time today. And thank you for providing your insights and knowledge here into this.
Yeah, thank you, Kevin. Thank you, Natalie. Thanks, Terlin. And those questions, there were some outstanding questions. You really kept me on my toes, and really, really nice questions. So thank you.
There we go. Great. Well, we'll move on to the next part of our agenda today, and it really is our guests, our other guests, our alumni. So we have a few alumni from the MM and also the MBAN program here. Now, Terlin's probably going to add into the chat box after everyone has said their thank yous, the different chat rooms that we have built out here. So I'll just, before we do that, before everyone leaves and jump into the other chat rooms, I'll go ahead and just give a very, very quick introduction to our alumni. So the first one I'll start with is Charlie. Charlie is a 2020 MBAN graduate. He had completed his bachelor's degree in apparel design and was also a product analyst intern here at UBC before he has become a data analyst at Best Buy. Vaishali is a 2018 MBAN alum. She has a BTech in computer science and a wide variety of experiences in both India and Vancouver before becoming a senior analyst in marketing analytics at Electronic Arts. Karan Shiraz is a 2018 MBAN graduate also, has a BTech in computer science, and has experience working in both tech, healthcare, with Boeing and also the First Nations Health Authority. And he's currently a senior product analyst at Hootsuite. Adnan is a 2020 MBAN graduate and has a background in chemical engineering and interned at Providence Healthcare. And after graduation, he is now a business intelligence developer analyst. And Manan is a part of the UBC MM class of 2021 and actually has a Bachelor of Law and practiced law for many years before becoming a business development and sales development representative at Hootsuite. So these are some of the alumni waiting for you in our breakout rooms here in the chat box. So before we all jump out into those breakout rooms, I just want to thank all of you for coming out to the event today. Come to the breakout room to have your admissions related questions answered. And again, thank you so much to Dr. Shechter for his time today. So virtual round of applause, everyone. And we hope to see you in the breakout room. Thank you again, Dr. Shechter.